So we've got all our software installed for making some maps. So let's talk about actually making some maps, because that's much more interesting than watching a terminal thing do something boring for half an hour. So this is this is just a picture, because this map takes a really long time to process. It's all the suburbs in New South Wales, so you can see how they get pretty big as you get far out, and then as you get closer into the city centre or up by Newcastle or wherever, they get pretty small. So they, in theory, from a practical voting point of view, they should all have about the same number of people inside them, but who knows? Let's find out. Right, so we've done all our stuff here where we're going to install our software. If you haven't seen that video, you should watch it, because it teaches you how to actually install your stuff. And so this link is to the data set of the New South Wales suburbs. If for some reason you are doing your data analysis project on an area that isn't Sydney, so I don't know, Tasmania or Atlanta or whatever, shapefiles for that area should be available from their local government or their state government. Alright, so we're going to import some stuff, and we're going to set some variables. So we're just going to import OS for interacting with the operating system, GeoPandas, which is like regular pandas but for geographical stuff. Shapely, Fiona are ways of handling geographical manipulations or creating shapes. Matplotlib and pyplot we've seen before because we use them for graphs. NumPy is like heavy duty mathematical lifting stuff, and pandas is, well, pandas, and we've used that for a couple of weeks now. So the shape file we want is this, the New South Wales locality polygon shape, and that's coming out of a zip file because we download it as a zip file, and this is where it lives on the web. There's a bit of code that comes up that unzips the file, and you can understand that if you like, it's up to you. So that's how it does it, the unzip file, and this is the thing that sets the size of the graphs. So this one just downloads, checks whether it exists. If it exists, it loads it from the file. If it doesn't exist, it downloads it and unzips it, and then once it's done that, it's already available to be loaded from the file. So we don't have to actually do anything here, we just do it in the next file. So let's clear all our outputs and then run everything above, and so everything's going to be kind of exciting. So what we're doing is going to be sort of adjacent to GIS stuff, and you are going to be doing some GIS stuff in a later course, I believe. So just think of this as a kind of a little starter, I guess. We're going to import the Sydney suburb stuff from the shapefile, and then we're going to set a CRS. Sydney has, we want to use that one, it should be that one. So Sydney has this MGA, Map Bureau of Australia, that's set, I think, down on the steps at Circular Quay as the origin point, and that is a flat plane that travels through Australia that you can do easy layout stuff on. It's sort of bizarre, but it's what you have to deal with. Everyone uses it here. It's very strange. And so let's load that up and have a look. It takes a little while because there's a lot of suburbs. Alright, so there we've got a bunch of columns. Now there's some junk columns in there like Loca 1, Loca 3, Loca 4, and Locos 5, 6 and 7 are also junk. So we're going to drop them out. We don't normally drop them. I don't normally drop columns because there's no harm in having them. But we're going to be looking at this data frame. So let's kind of have a nice clean looking data frame. So if we do this drop, we're going to do it drop columns. We're going to do it in place, and we're going to ignore errors. And we ignore errors because if we try and drop something twice, it'll complain. So we've got six, yeah. We've got the geometry column, which is the polygon of the outline of the suburb. We've got the name of the suburb, and I guess this is a date. Makes sense. I don't really know what it does. Let's leave it in there. Where's the postcode gone? I don't know where the postcode's gone. Well, the PID has the postcode in it. I think that's postal ID. I'm not sure where that's gone, but whatever. So if we want to get the thing out of it, we'll have to pull it out of there using an apply. But we've got our geometry column, so that's great. This next bit here will plot the geometry column, but you don't really want to do that because it will take a long time. A lot of people do it just to see how long it takes, but don't do it in class because it will take you like half an hour. So using sort of standard pandas type stuff, we can use iloc to get the first row out. And we're going to print the value, and we're also going to we're going to just let it return the geometry value of that row by default. And so magically it returns the geometry thing as a drawn shape, which is pretty cool. And then this is what the row looks like. So it's basically just what we were looking at a second ago, but with this kind of nice output. And if we want to do a distance between two things, we need to do distances between points, because it doesn't make sense to do distances between shapes, because do you mean the closest part, the furthest part, the centers? So let's go through and apply, we'll create a new column that's just the centroid of each of those suburbs, and that will allow us to do some things a bit quicker. So we're going to make a new function that just pulls out the centroid, and we're going to use an apply to create a new column called centroid. And that's nice. And if we plot that, we can see all of the suburbs in New South Wales. And we can kind of see the coastline pretty clearly because there's suburbs tightly packed all along the coastline. Something to think about here is that we're seeing this differently to a scatter, because a scatter would squish them and not show them in a kind of useful way. Now we've got this weird dot out here in the ocean, and I haven't dealt with that, so let's see if we can find out what it is. So we'll look at this, and the centroid is okay. So the centroid is a point object. We don't have a direct access to the individual things, so let's pull out the first value, which is the latitude, and we'll try and work out what the max is. So burbs that equals burbs dot. Now, if we're going to do an apply to pull out that value, we can do a little lambda. And I don't really like lambdas because they're a bit hacky, but sometimes it makes sense to do something kind of small. So x, I'm pretty sure this will work. Let's have a look. Okay, so we can't subscript it. So what is in a point? So let's go back up to here where we can see this point and find out. So burbs dot iloc 0 dot centroid. Okay, so that plots just the point. Now if we want to find out what we can do with it, Python has this feature called dir, which tells you everything that's inside it. So we can look at all these things and find out all of the properties it has. So what we want to get is, just kind of look through this. Maybe .x. Let's have a look. See if we get a number like 150. Yeah. Okay, so it's easy. It's just the .x. So I can delete that and come down here and say it's actually x.x. So let's call that p. So now we've got a lat value. Okay, and now we can say we want to get the index of the row that has the highest lat. So we want to say verbs.lat.idx max, and then we want to pull out the row that has that value. So let's just have a look, and we'll say verbs.lock and then idx. Okay, so that is correct. So it's showing the centroid of Lord Howe Island. So that's kind of cool. So it shows you where Lord Howe Island is, just off the coast, right out here. So there's not a problem there. Often you'll see problem suburbs that are problem points in geographic data sets, and you have to kind of find a way of working out where they are and whether you can take them out. But in this case, we do want to keep Lord Howe Island in. The difference between lock and ilock is lock you index with the index of the thing. So in this case, these are numbers, but they could be anything. So if that was set, the index were like animal names, it would be like python or panda or horse. But ilock is going to be the number, so it starts with 0 and goes up. So often you'll get a date thing or whatever. So this is just lock is the index, ilock is the number of the row. Alright, so we know that Lord Howe Island is correct there. We don't have to worry about it. So if we look at this now, we can see that the first, using ilock, the first row, the first suburb, has a centroid, which is this point here, which is nice. And if we want to make a new point, so if we want to do some distances from those centroids to a new point, in which case this is going to be the distance from UNSW, that point, I got this from Google Maps, it's just the coordinates of the Kensington campus. And we've made that point, we call it right here, and then we just make a new column called distance from UNSW and just do a distance, and it's from all of those points, each one of those points, to the right here point. Now I've been trying for ages to work out how to convert that so it does distances in meters rather than just a kind of Pythagoras of the lat long, but I still have no idea. One day I'll figure it out. But let's plot the distances, and so we can see that quite a lot of suburbs are close-ish to UNSW, and then it sort of drops off into distance, and then at some point we get this hard drop off and it becomes basically rural. So we can see that in the map, that like lots of things are close, and then there's some more stuff out here, and then it drops off a little bit, and then it's like poof, nothing. So that makes sense, that works. So we can use Boolean filtering again, Boolean masking. So we want all of the things with a distance of less than 0.05. Now this is where it gets weird. It's not meters, it's in coordinates. So that gives us just these suburbs, because they're the ones that have the centroids that are close-ish to UNSW. And we can represent those things in a few ways. So if we want to represent the complicated suburb boundaries, we can just plot them, or we can go a little bit harder and say, okay, give me the convex hulls, which is like putting an elastic band around something. So you can see there's no inside corners to any individual thing. And you can also do just draw a square around it, like a bounding box. And so that's useful if you're doing kind of a lot of these kind of calculations to see if something is close. This is kind of a games programming idea, but it's sort of shows up in this kind of thing if you're doing a lot of testing to see if something's inside or outside of things. So let's do some more, do a couple more things, and then we will see how we're going. So let's put some names on the map. So we're just going to use plot annotate, and annotate's super useful for all sorts of things. And you're going to be wanting to put that onto like a heap of your graphs to sort of do these annotations. Now there's nothing kind of magic here. It's just saying put in the text, which is in NSW Loco 2, which is the name of the suburb, and then we do a bit of magic here where we convert that centroid's coordinates into an XY tuple, and then we say, okay, do it in the data's coordinates and center the point on the centroid of the suburb. And so now we can see that, like, okay, well, that's PageWood. Now this is where suburb polygon centroids become a bit tricky, because PageWood centroid might actually not be inside PageWood because it's got a kind of loopy shape to it. So that's not necessarily great, but it'll do for the moment. So what about if we want to say, okay, I've got a data set that has coordinates, and I have another data set that has suburb names, and I want to join the two up. So I can test a coordinate to see if it's inside a shape. And there's a whole bunch of different ways of doing that, but the easiest way to think about it, if you ever have to do it yourself, is if you cast a ray from a point, if it crosses the boundary an even number of times, or 0, it's outside. And if it crosses an odd number of times, it's inside. It's pretty straightforward, but what we're doing here is we've got one already built in. It's called within. And so if we run that, we can say which of these is inside the thing. So what it bizarrely shows us is that the point that UNSW is in Kensington. And so we didn't tell it that that point was in Kensington. This bit of code just kind of went through it and found out. Now that's running on the really close burbs subset dataset. If we were running it on the whole of New South Wales, it would probably take a fair bit longer, because it's going to see, you know, is UNSW in Orange? And it'll be like, no. Okay. Is it in Newcastle? No. And so this, if you run it against all of your points, against all of your suburbs, it might take a pretty long time, because that's an n squared operation. It's a pretty heavy duty n squared operation too. And you could do the same thing with a lambda, which in this case we've got it set up to do a filtering thing which gives you the row of the dataset, which is nice. Now sometimes you want to show some data on a map rather than just putting some points on. So there's a type of map called a choropleth, which colors your map according to the data. So in GeoPandas that's super easy. You just say which column do you want it to address. And so if you had GDP, or you had number of schools or whatever, you just change that from distance to UNSW to GDP, and it would color it according to that. And then you give it a color map, and GeoPandas will show you that on the website, and it will color in your map accordingly. Okay, so the last thing is if we wanted to put some points onto the map that's already been colored in. So we've colored it in using all of this stuff. All we have to do is assign it to a variable called ax. We can call it anything you like. But then when we come to plot the second thing, which is just the points, we want it to be plotted on the same axis. So ax, in this case, equals ax. So saying the axis that we want to plot these points on is the same as that one. So now we've got the map colored in by distance from UNSW, and the centroids are plotted on there. And so you could do that with showing all of your schools or showing all of your petrol stations or whatever you want. And you can say that suburbs that have a lot of schools also have a high GDP, or where the schools are, or whatever you want to do. And so that gives you all sorts of options when you're actually producing maps. And so here's some links. There's tons of stuff out there. GeoPandas is still used a lot. So there'll be loads of tutorials. We can see the color scales. There's all sorts of stuff. So play with it and see where you go.